Welcome back. Today we're building another static phase converter. Same principle as we had in an earlier video. I use that regularly, but Alan, I put a link to his channel down there. A fellow YouTuber needs one because he bought a surface grinder. So we need to mock one up for him, and his Sparky can actually wire that in correctly. I just do the sample wiring and put it on a piece of wood so he can do whatever he wants with it. Basically just to show it works, and that's about it. I'm not going to do the installation for him. Someone else is going to do that. Alright, so we talk about a few things while we put it together, but the main principle and the drawing is actually in the video. I put the link in the description when I made the first one, just to show it's actually working. We need a piece of wood. Bolt this stuff down, make sure it doesn't get ripped off in transport. Probably put just some flat steel underneath the wood so it doesn't get ripped off. Put something on top of it. Wire the thing up, give it a brief test, set the parameters on the inverter right. So he's got a plug and play solution, sort of. Alright, let's do that. We'll take some clips during the assembly process. So we drilled some holes, we made some brackets here. They go behind because we're gonna ship that and the screws may rip out of the wood, so we put them this way. That's the wrong hole. We put them this way, and once he's got it, he can turn them around and mount it to the wall, like so. And for shipping we just turn them around. So they're out of the way on the back, obviously, because the transformer is very heavy and we don't want to get that damaged while shipping. Okay, so let's fit that transformer to the board. Need to find some screws and washers. Alright, we'll come back when the transformer is fitted. So we wired it up. We need to test it and then we'll prettify the wires a little bit. Mains in, 230 volts in, breaker also as a switch, transformer 400 volt into the inverter, and 400 volt 3-phase out. We need to fire it up, check if the phase of the coils is correct, and we should have about 430 volts here. And as far as I know, his machine runs on 415, so we set that to 415 50 Hertz. So let's put a wire on and fire it up. So we're ready to go. One word of warning: do not do this at home. Electricity is dangerous, and if you don't know what you're doing, just leave it alone. It's not fun if you get killed with these things. This is not an instructional. It only shows how I do it, and if you're not qualified, you shouldn't touch electricity. Okay, we got mains voltage here on my terminals, 238 volts. We power the thing up. We got 237 here, and we got 440 something here on our inverter. So the phasing of the coils is correct. We got 110 here, 104, 104, so that's 209 plus the 230 is about 440 something. Okay, so first of all, this is a brand new inverter. We need to set some parameters, because when they come, they usually set to some weird frequencies. Just need parameter 2, I think. So that's we want the panel. So that's frequency on the panel. Parameter 3 is maximum operating frequency. That's set to 400 Hertz. That's no good. We want 50 Hertz. Or make that 55 or so. I'll make it 55. That's fine. So our base frequency is 50 Hertz. That's parameter 4. The base frequency is the frequency we want full voltage, and in this case it's 50 Hertz because he wants 50 Hertz, 415 volts. So that's parameter 4 is base frequency, and we want to set that to 50 Hertz. So that's set. Maximum voltage is parameter number 8, so we need 8, and at the moment that's set to 380, we want 415. So I guess this motor is 415. We're running at 55 Hertz. We put that down a little bit. Make that 50. And run. Stop. Run. Yeah, 50. So we should have 415 volts on our output terminals, about. At the moment we're measuring garbage because there is no load on it. You can hear the... We need to put some load on so you can check the voltage. So what we also need to check is our motor ratings. Even if we don't have a motor, we need to tell this thing what our maximum ratings are. So that's parameter 141. This is 400 volts, or 415 in our case. 415. Set. And our maximum current, which is 142. It's set to 8.5. The inverter can actually do 9, so I would set that to 9. No, it doesn't let me. Well, maybe that's the maximum rating. Yeah, that's the maximum rating of the inverter. Okay, that's fine. So the rest of it doesn't really matter because we don't care. We don't care what the revolutions are. As soon as we load this thing, we will see 400 volts. At the moment we don't, because it's in sort of self-protection mode, and we will put some resistors on the output now to show it's 400 volts. We can hook up a motor as well. Well, we'll see. We'll put something on. By the way, I fitted some ferrite cores. We need to tie them a little bit better to get rid of at least a little bit of the interference of this thing, because there's absolutely no filtering at all, and that's not a good thing. So let's switch that off and find some resistors. So we hooked up the surface grinder, and I'll fire it up. Got the surface grinder, the mill. Okay, let's fire up the mill. I thought I had the surface grinder connected, but he was actually the mill. Okay. Pulling a little bit more load here. This meter's garbage here. Let's see what we have here. So that's our DC voltage, and that's our output voltage. If we stop it, we can see it goes down, and then we fire it up again. This is our output voltage, and come on. That's our current. We're not drawing a lot of current at the moment. The problem is that the meter is reading garbage. It's a cheap meter, and it reads 500 something volts, but it's not. It's 415 volts, but it's pulse width modulation. Let me stop that. It's pulse width modulation, and what you see is the spikes, because it's not really a sine wave, it's something weird. I put some resistors on, it doesn't really help. We should put some capacitors on, may help a little bit. The fact is it works. I can run that. Mill is running, and look at the current here. I've got everything running on the mill here. So, in the mill, current goes down to almost nothing. And then run the miller on high speed, everything is fine. So I don't know what the current was saying. I was actually reversing the mill active. I was putting it into the reverse, so it was pulling some current, and looks good to me. Everything seems to work. That's what we want. Again, 230 volt in, transformer. The output of the transformer in series with the mains voltage gives us about 440 volts input to here, because this is a 400 volt inverter. This thing runs 50 Hertz, 415 volts, and that's what we get out here. 3-phase, 415 volts, maximum 8.5 amps, 4 kilowatts, providing you supply enough current on the input, because obviously at 230 volt the current is a little bit higher. That's it. It's precisely the same as the other one, as the prototype I built with that yellow inverter. This is just a quick one. So he's got everything on a plate here, and what he does with it, I don't care. It's gonna be covered. It's not safe as it is right now, because you can touch live components. But it does work, it does the job. His Sparky needs to check for electrical safety and everything. Make sure he's happy with that when he wires the thing in. And obviously he needs a cover, because yeah, nothing is actually touch safe here. Alright, everything is grounded. Inverter is grounded, transformer is grounded. The breaker is the maximum rating of the inverter, plus a little bit of inrush current, 20 amps. That's what the whole set can do. But it's going to have an external fuse, whatever the rating is of his supply and his cable. That's what he needs. The cable work is good for 20 amps. This cable work is good for the 9 or 10 amps, which comes off the inverter. So this thing is okay so far. The supply is not my business. It's his one. So well, we just put some cable ties on and tie these cores a little bit here, so they have a better effect. That's about it. Some cable ties. Wrap it, pack it, ship it. Make Alan happy, because he bought a surface grinder. I'm actually keen to see how this thing looks like. I think it's quite a big one. This setup works pretty much for any voltage. It doesn't matter what the input voltage is, as long as it's higher, or at least equal, or a little bit higher than what you need. So if you got a 280 volt, if you got a 208 volt 60 Hertz motor, set that thing to 60 Hertz, 208 volts. Make sure the current rating of the inverter, which is on the nameplate, is good enough for your motor. If you go lower in voltage, this thing will not have 4 kilowatts. At 208 volt it may have probably in the region of 2 kilowatts, because it has only 8.5 amps. So it's important to understand that you don't buy kilowatts in inverters, you buy current. Obviously you buy a voltage rating as well. This thing is rated for 400 volt plus minus 20%. But the main thing which costs you money is the current. You know, if you buy a 4 kilowatt inverter for 230 volts, it's actually a higher current rating. If you look at the other one I have here, this thing says 18 amps at 230 volts. This one says 8.5 amps or 9 amps at 400 volts. Both 4 kilowatts, because power. I know someone will talk about power factor. Well, we'll leave that alone for now. Power is actually voltage times current, and at a lower voltage you need more current for the same power. That's the reason why the 230 volt is actually has a higher current capacity, but the problem is you don't have the if you got a 400 volt motor, you need that. You need 400 volts. What's that noise outside here? Again, if you got a 208 volt motor, you can use a 230 volt inverter. Run that 208 volts, 60 hertz, and your motor will be happy. Or whatever machine you have. The only downside is you don't have a neutral. You don't have a neutral related to the three phases. It's somewhere in the middle, because we basically feed neutral 0 volts and 400 volts single phase into that inverter. So the third terminal stays free, because we only feed it with single phase. That's another reason why you need a slightly overrated inverter, because the capacitors are designed for 3-phase, where the intermediate voltage, the bus voltage, is a little bit higher than with the single phase supply, because the ripple is 150 Hertz instead of 100. So there are a couple of things to consider if you do these sort of weird setups here, but technically it works fine. What you shouldn't have is long cables on the output, because this thing is always powered, and these are antennas here, you know. This is not screened, this is just for testing. Again, keep the cable short, use screened cable, CY cable, for the outgoing voltage, and the whole thing should be in a metal box, so it's fairly screened. Any questions, let me know. If I can, I'm gonna answer them. So we tidied up the cable work a little bit. Probably one word, the transformer only needs about half the power, because we're feeding 230 volt into the transformer and getting 230 volt out or 220 volt out, and put that in series with the mains, so the transformer is only doing half the work for this particular setup here. You can do it with 2 transformers, or with a 400 volt or 230 400 volt transformer, but then you need a full rating on the transformer. Saves you a bit of money on the transformer. The only thing you need to make sure is that the transformer is actually good for the insulation of the transformer, is actually good for 400 volts. I checked them with 1000 volts and it's fine. These are isolation transformers, that's what they're supposed to be, and it's 2000 VA, that's 2000 watts with a power factor of 1, so it's probably 1.8 kilowatts, because this thing is producing a bit of power factor here. I need to check what voltage setting he wants, but I think he said 415. You can easily change that with the appropriate parameter. Just set the max voltage to whatever you want and leave the frequency as it was, 50 Hz. And also the run command. At the moment you need to press the run button. If you don't want that, it needs the link and changing one parameter, and that's about it. It's a standard Huanyang inverter, 4 kilowatt, 400 volts. Oh, it says 380 here, plus minus 20%. So we read at the top edge of the inverter rating with 440 volts. It depends on the mains voltage. Nominal voltage here is 230 volts, but we actually have closer to 240, sometimes 245. In the house I've got 245 to 248. Here it's a bit less because there's a long cable into the shop here, so it's always a bit lower, but causes other problems. Let me try higher switching frequency if that makes a difference. The problem is if you increase the switching frequency of the inverter, you need to downrate it, because I think it only does full power at 3 kilohertz, and that's when you hear the whistling. If you go higher with the switching frequency, it's actually parameter 41. The problem is that you're producing even more interference. I set it to 4 already, make it 6 kilohertz. You can crank it up to 15. The problem is that the thing makes even more noise and you cannot pull the 4 kilowatts anymore. Let me see if that makes a difference. Not exactly. Doesn't make it any better. I can see transients up to 260 on the mains. I tried my other meter. Where is it? Yeah. That's actually a bit of a better meter, but it doesn't like the transients at all. So see what that reads. It says 600 volts, which is garbage. What you're seeing is actually the 600 volts is the, if you look at the 630 volts is our DC voltage in the inverter. If you run it, it goes down a little bit to 570. Clear indication that we actually need more capacitor, but it's okay. See if you stop, it goes up to that voltage here, and so that's the idle voltage of the rectified mains, 415 volts or 440 volts in, times square root of 2, because it's only single phase. If three-phase rectifier, it's about 1.6, so it's more like 680, 690, which is probably a bit too much for that one. 630 is fine, and again it drops down as soon as you run, because we have technically a little bit too less capacitors inside. That's the reason why for a 3 kilowatt setup on a 13 amp supply, that's about 3 kilowatts. That's what I get out of it. The 4 kilowatt inverter is just fine. A little idler motor will probably help to get the spikes down a little bit, especially if you run an old motor. I would recommend to crank the motor voltage down a little bit to 405 or 400 volts. Depends what's on the nameplate. If you go 5% lower, it does help to increase the life of your motor, because what it does, these high voltage spikes are not good for your insulation if you got an old motor. So you rather want a little bit lower, or proper filtering on the output. It's your choice. Okay, and that's the reason why you should never trust a digital multimeter. No matter if it's a cheap one, rather cheap one, not the cheapest, but a rather cheap one, nor the expensive one I had before. They all do the same. The reason why they're reading too much is the internal resistance is too high, and so they're reading peak voltage, and the peak voltage is actually the DC voltage, which is 560, 580 volts, because it's pulse with modulation. It just cuts this 560 volts into bits, and because these meters are not consuming a lot of power, all you get is an average, which is the 560 volts. So we hooked up a good old analog meter, which is a moving magnet one, pretty slow responding panel meter. One division is 20 volts, so that's 400, that would be 420. We fire it up, and you see the voltage is coming up, and we're reading between 410 and 415, which is okay because it's a good old meter. I measure on the same terminals, and oops, and our lovely meter is reading 570 volts, 580 volts. So put it on top of here. So it's reading 560, 580. That's our DC peak voltage, what we're measuring here. But this good old thing here, which I'm only going to touch with a glove because it's a metal case and it's not grounded, so I'm going to be careful, just in case it's not visible. It's reading 400 volts or 410-ish volts. 450 is our target. So hopefully that proves the point that we're actually having 415 volts. So let's say if we change that to I think it was 8. It was 8. Yeah. Let's change that to 400 so you can see the difference. These are live parameters which you cannot change while it's running. So change that to 400, set, run, and as you can see we're reading just under 400 volts or just about 400 volts, whereas our fancy digital meter reads still 560, 550, which is about our DC voltage. Yeah, so it proves analog technology is sometimes much better than digital technology. Let me switch that off, getting quiet here. And you see the two red wires are going to the same terminals I was measuring. It's open terminal, it's a metal case, so I'm going to be careful. This is an old meter, you never know. Yeah, again, imagine you got 560 volts or 580 volts and it's just cut into slices, but this meter does not consume any power and it's too quick, so it basically just reads the peaks, which is very common on these things. Yeah, so if you measure something, always think twice, is it possible or not? And I did know it's not possible, so that's the reason why I tried something else. It also shows that you shouldn't always believe what you see. Always double check. Think about it. Is it possible? Is it not possible? Where might the error come from? There is a good reason that I keep old equipment. Same with analog scopes and digital scopes. Same thing. Sometimes you see something and you think it can't be right. I think that clarifies that is actually a measurement error, not a system error. Alright, let's carry on here. I need to put some labels on here so that he knows what it is. And then we crate it up, and that's about it. Job done for today. That's it from this one. Not much more to say. Any questions, let me know. I'll try to answer them. Thanks for watching. Thanks for subscribing. Until next time.